Hi, everyone, and welcome to Generative AI using ChatGPT and Stable Diffusion to create comic strips. My name is Greg Loughnane, and I'm leading the product and curriculum team at FourthBrain. We appreciate you taking the time to join us for this event. If you're joining us live, then good afternoon. If you're near me, I'm in Ohio in the US. For the rest of you, good morning, good evening, or thanks for staying up. Wherever you're joining us from, please say hello in the Zoom chat now and let us know where you're calling in from. We're super glad to have you here. Our interactive demo today is a collaborative event between DagsHub and FourthBrain, and is a workshop that represents the next evolution in a series of recent events that FourthBrain has done in collaboration with companies including Deep Learning, Hugging Face, Iterative AI, the makers of DVC, and Databricks, the makers of MLflow. I'm joined today by my good friend and colleague, Ali Kadhim. He serves as the MLOps product lead and instructor at FourthBrain, where he has been working closely with me to design course curricula and to teach MLOps courses. We are both big fans of DagsHub because, as you'll see, it provides a powerful set of industry standard best practice MLOps tools all in one place. Many of our students at FourthBrain have chosen to leverage DagsHub for their capstone projects, and today we'll show you how you can think about leveraging tools from DagsHub, Hugging Face, DVC, and MLflow to showcase your next machine learning project. Two final housekeeping items. First, we'll be taking questions directly on the DagsHub Discord today, and we'll be answering the most upvoted questions and the most comments and the most replies to questions following the demo. And we'll go ahead and drop the link to the Discord channel in the chat now. Second, we wanted to share the DagsHub repo itself with all of you that we're going to be using today straight off the bat. So you can just kind of settle in, enjoy, and follow along. So without further ado, let's get into it. So welcome, everyone. What we're going to do is we're going to kind of put this whole story in context first before we talk about how we're going to create our proof of concept to develop a baseline model. We're going to iterate on then our custom model using a data-centric approach. And we're going to leverage data and model version control as well as experiment tracking. And we're going to sort of differentiate between all of those for you before we deploy our generative AI app, and we end on some conclusions and Q&A. All right, so first up, Ali, we've got a heck of a story to tell. Not so long ago, how did this all come about?
Sure, thanks, Greg. So this all started a while back, about a month and a half ago. I wanted to create a Dilbert image to share with people on LinkedIn, to encourage others to create images and everything like that, but I was doing it in Midjourney. And I went through like over 100 iterations of going through this. I was really excited to share it, but I couldn't do it. And that was the problem, is as much as I tried to make Midjourney work, it's just, I couldn't do that. And so when this DagsHub opportunity came up, I knew what I needed to work on. So about a week ago, I also saw this little comic strip come out by Scott Adams himself, who makes Dilbert. And when I saw this, I knew it was the right decision. This is where our story begins. Greg, tell them about what we've been doing since then.
Awesome, Ali. Yeah, I remember him working really hard to try to create an awesome Dilbert image, and it was much more challenging than we originally thought it might be. And so the story of what's happened since then starts now. Originally, ChatGPT was used to create a pretty cool, we think, Dilbert comic strip and joke, which we'll read for you shortly. And then we wanted to leverage diffusers because Midjourney, while it's not open source, diffusers is an open source way to leverage stable diffusion. And then we started iterating on our baseline model. And we did that by tracking our experiments and by leveraging data and model version control. Lastly, we went and we deployed an AI application directly on Hugging Face. This is very powerful when you get out of the notebook and you can leverage an app directly. And Gradio has a really amazing one-click deploy functionality that really sets you up to do a generative AI application just like the one you'll see today. So all of this comes together in DagsHub today. And that's sort of the story that we're going to tell you. And when we think about a complex project like this, one of the best ways that we can visualize this is with something called, you guessed it, a DAG. And the DAG that we've developed within DagsHub looks something like this. And we'll sort of walk through each step of this throughout the demo today. DAGs are super useful for describing complex processes, structures, and project management systems. So if you can sort of walk somebody through visually what you've been working on, it's a very, very powerful tool, especially for data science and ML practitioners. And, as mentioned, you will get access to all of the code today. We're going to show quite a number of different things. So we'll be dropping links in the chat throughout. All right, so let's go back to the beginning as we set out to create our proof of concept. Now, one of the things that was really funny and cool about all of this is that when we started, ChatGPT really produced a great result. And of course, the classic Dilbert comic strip is 4 panels. So we had it create a 4-panel comic strip for us directly. So Ali is going to play Dilbert here, and we're going to do the joke for you. All right, let's take it away.
Yeah, I'm building an AI to automate my job.
Dogbert. That's a great idea, Dilbert. I'm sure it will work perfectly.
I finished building the AI. I just need to test it.
Coworker 1. What does it do?
It's supposed to do my job. It's working perfectly.
Coworker 2. What's it doing? AI. I'm automating Dilbert's job.
I guess I should have seen this coming.
Dogbert. I told you it would work perfectly. The end. Okay, so we really liked this joke, and it didn't take a lot of iterations on ChatGPT to be able to do it. And so the next step from here, because ChatGPT produced not just the joke text, but also the situational context, the description of each panel and what was supposed to be in the image. So for today's presentation, we're focused on images. The prompt that you see below, Dilbert and Dogbert are sitting at the dining table. Dilbert is holding a laptop while Dogbert is looking over his shoulder. This was prompt from panel 1. And what we did straight off the bat is we said, hey, can we leverage Stable Diffusion straight away and get decent results? And, are they decent? Well, we'll let you decide on that. Stable Diffusion 1.2 looks a little bit like Scott Adams. Dogbert is clearly looking a lot like a dog, and really not quite sure what's going on there with 2.1. But we see laptops on tables, so we're not completely off. All right, so where did we go from here? Well, the initial model results that we got with Stable Diffusion 1.2, we sort of looked across what we were able to create just without any fine-tuning whatsoever. And we also looked directly at our prompts because we started to see some patterns, right? We started to see people are always sitting. We started to see there's computers. There's always sort of a screen in play. There was always somebody looking over someone else's shoulder. And we start to see a few key characters pop out within the joke that we're trying to tell. So this gave us a number of hypotheses about what we could do to improve this data that we'll talk about after we show you directly how to implement this, not through a Hugging Face application that's already built, but instead through your own Python code. Ali, can you show them how to do this directly with diffusers in our Google Colab demo notebook?
Sure, Greg. Thanks. So going through this, we're just going to do a basic inference. And this is in Google Colab. I use Google Colab Pro with the GPU, with the premium GPU running through this. So to start off, we are going to install Hugging Face diffusers, and we installed the requirements as well. We cloned that and then installed it. And then what we did after that is that we were able to start going for the inference. So we imported the stable diffusion pipeline from diffusers, imported PyTorch, and then went ahead and declared our model. And from there, we were able to say we want to process it with CUDA. So this is the architecture that we're using for processing through the GPU. And we went ahead also and added this prompt. This is the prompt directly from ChatGPT. And these are the results that we got for, this is the first one was Stable Diffusion 1.2. He's got a laptop, so that's an improvement. And so going ahead also with Stable Diffusion version 2, we did the same thing and we were able to acquire this image. Also, he seems to have a little device there. So that's good.
So pretty straightforward then to knock this out, Ali.
Yeah,
kind of cut and
seems
paste
so.
code. Yeah. So this is kind of how we got started. So this sort of developed our baseline. And then what we wanted to do is we wanted to say, hey, we've got our baseline. We believe we can do better. Now it's time to start iterating. So as we move from baseline modeling to now we want to do a custom project and a custom model, the really important thing is to start doing things properly. We don't want to end up with 1,000 notebooks, and we don't want to end up with a giant spreadsheet full of random experiment data with data all in random places. So the best way to do that is to give ourselves a container, a repository in which to work. And that's where setting up DagsHub really comes into play. So what we're going to do now is we're going to walk you through what our DagsHub looks like and how to set up a quick new one yourself. Ali, go ahead and show them how it's done.
Sure. So this is our current repo for our project. And you can see over here, here are all the files for our project, and then as well as our DAG. You can click here and take a look at the whole entire DAG. And so it's like, well, how do you create something like this? Well, if you click up here on the top right for create new repository, you get to this page over here for creating a new repository. And from here, we can just say, here's our Dilbert test comic strip. We can give a brief description, such as this is a repo for creating Dilbert comics. And for the project template, we'll keep it as custom. This allows us the ability and options to use DVC or anything else that we may want to use. For git ignore, we'll go ahead and make sure it's Python. And I typically, for the license, like to choose MIT license. And then we'll have our default README. Just click create repository. And there we go. So this is our repository available. And now we can start working on our project.
Very cool. Yeah. So it's as easy as that to get set up. And as we walk through today's demo, as mentioned, we will walk through sort of each of these key pieces of our DAG that sort of represent the project structure. All right. So next up, what we're going to talk about is just this fine-tuning process. And when we fine-tune a general pre-trained model or a GPT, what we're really doing is we're trying to say, hey, can we take this baseline output and can we try to make it closer to really what it is that we're looking for by feeding it some very specific data? And this is where the focus on data, the focus on really on small data starts to become very, very apparent. And you'll sort of get that flavor throughout the presentation today. And of course, many of you may have heard the most recent buzzword talking about doing things in a data-centric way. And this is really what we're talking about. We're talking about curating data to do things like fine-tuning large pre-trained models. And this is really what we set out to try to do with Stable Diffusion. The way that we did this was we tried to find images on the Dilbert website, comic images, and then split them up because we didn't want to put 4-panel images directly in. We split them up using a grid splitter. There are applications out there. We've actually got a custom one that Ali built that's on the DagsHub repo now. And the thing that's interesting about Stable Diffusion is that you can sort of mimic style, overall style, and you can also mimic objects when it comes to trying to get the image right. And so we were kind of playing with a number of hypotheses, looking at specific characters. If we fed it specific character data, would that actually produce better results? Or if we focused more on backgrounds and style, would that produce better results? And so also interesting to keep in mind, this is all sort of an unsupervised learning approach. And although you can sort of put data in and name it in interesting ways to try to get the general pre-trained model to try to pick up on things, but we'll sort of walk through each step of this that we went through. So Ali, tell them a little bit about the journey in terms of what didn't work so well.
Sure. So, I mean, my dream for this is really to be able to create images for Dilbert and have it be any character that you want. So for this one specifically, since we started with ChatGPT and it created these prompts, what I wanted to do is I wanted to make sure that any of these characters I could type in, and within these prompts, it would generate the image properly. So I focused on trying to first see if I can focus on these specific characters. As I focused on these specific characters, I generated 3 images for each character. And that was just using the grid splitter. So using the grid splitter, I had Dilbert, 3 images for Dilbert, the AI robot, coworkers, and Dogbert. 12 images total. And I went ahead and trained on this for Stable Diffusion 1.2 and 2.1 for approximately 1 hour. This is using the NVIDIA A100 from Google Colab Pro. That didn't work. Here are the results. And it's like, what happened is in Stable Diffusion 1.2, you get some of these black images. That's because there's an algorithm within Stable Diffusion that's been implemented for not safe for work. So when an image is generated and it's not looked at as not being safe for work, it automatically blacks the whole image out. And then for Stable Diffusion 2.1, we have this kind of like repetition as far as Dilbert just sitting there, and it's the same thing. So it didn't seem to work that well. Now, going to what worked better. What seemed to work better was if we took this other sample. I had 7 images of just a grid splitter where I just had each image being something arbitrary, so different characters, so on. You can see in here, this is actually the boss, the one in the orange. And so what happened was with these 7 images, I also trained 2,000 steps for 1 hour using the NVIDIA 100. And with 7 images, I got relatively better results. As far as we see, there's a little bit more of context as far as each one. And then the style is really good. So what's crazy is when we get to the fine-tuned model results. So as we look at the fine-tuned model results, we see that like in under 10 minutes, I only needed 400 training steps, and I was able to train in under 10 minutes and get these kind of results, which I thought was pretty incredible. Greg?
Yeah, wow. That is super cool that you got the hour down to 10 minutes. And overall, we were able to move from Dilbert looking not really so much like Dilbert to Dilbert really looking a lot more Dilberty. So I like where we were able to go with just an hour of training. And just remember, 7 images. Interestingly, we had all the characters in, and then the result was no characters, and so like very, very interesting things are happening with these GPT models behind the scenes. Why don't you show us exactly how we can take the code that we saw for the non-fine-tuned model and do some fine-tuning with some real Dilbert data?
Sure. So hopefully everybody can see this notebook pretty good. So what we did is that we created a notebook for fine-tuning this. This is using the training text to image from Hugging Face diffusers. And what we did is we installed Hugging Face diffusers first. We went ahead and installed the requirements. And then we used something with Hugging Face Accelerate. Hugging Face Accelerate is basically a platform that allows you to run on distributed systems and including single GPUs and also M1 chips. What's really awesome about this is that through one command, you can configure everything that you need. And so since we're using just a single GPU on the Colab notebook, we're able to run this with just this one command. And there are a few things here we'll get to later, which is MLflow. So we went ahead and installed that. And then this Hugging Face notebook, the notebook login. So to continue, we wanted to make sure that we declare our pre-trained model that we're going to start out with, and then the data set that we'll be using. Finally, we have the Dilbert comic for the output directory, and then we go ahead and we train. And just recall here that we will be reporting everything to MLflow and be pushing everything to the hub for Hugging Face. Now, with this, what we were able to do is that we were able to run through all of this and then have it do the inference. And when we did the inference, we were able to generate these images.
Very cool. Yeah. So simple as that to kind of generate these images. And so when we started to now really dive into our iterations, we started to look at this data set and that data set, create this model and that one, and trying to think about how to really get a handle on all of this. We really wanted to set out to showcase the power of some of the best practice tools in MLOps today. So Ali and I have been sort of teaching these tools for the last year and a half, more than that potentially. And, this is one of the real amazing things that we find with DagsHub is that they're really all in one place. It's important to understand as we walk through the rest of today's presentation that there's differences when we say things like experiment tracking and version control. So let's sort of outline what these are, because everyone right now is competing with one another. MLflow, DVC, Hugging Face, everybody would like to be all of these for everyone. But in terms of best practice tools on the market, this is what we believe is true and that you should leverage today. If you want to do experiment tracking to track the metrics and the metadata for each experiment, so that's both data and model information, that's trained model, that is where you want to leverage MLflow. And we'll see how that works in just a moment. When we talk about just leveraging data version control, DVC really shines here. And this is going to be focused on changes in the data set that we're using to do our training or to do our fine tuning. Whereas model version control, in comparison to both experiment tracking and data version control, again, is focused on changes within pre-trained and fine-tuned models in our case. And so the changes in the models versus the metrics and the metadata associated with each model, these need to be differentiated. So we'll see experiment tracking done with MLflow. We'll see data version control done with DVC, and we'll actually show you why we chose to do model version control with Hugging Face. Hint, it makes quick deployment a little bit easier. And just to sort of make sure that you're all clear on how these tools fit together, because it's a lot. We understand it's a lot to really take all this in. Experiment tracking with MLflow is something that's done through Git. And the basic premise of Git, whether using GitHub or any other Git tool, is that you're creating a local version that you can work and develop on your own machine with. Data version control does the same thing. It leverages Git. So it makes everything that you're doing connected locally to your machine. Where DagsHub comes in, and the reason why we really like it, especially for group projects, is that it makes both of these tools, MLflow and DVC, it creates a remote version of each of these underlying experiment tracking and data version controlling tools that now, if you're working across a small team, you can be working simultaneously, not on the same machine, but rather simply within the same DagsHub repo. This is a very powerful reason why we like this tool so much and why we think you should too, to do collaborative projects in the future. So with that, Ali is going to show us how the magic works here as he walks through MLflow for experiment tracking, DVC for data version control, and Hugging Face for model version control. Ali, take it away.
Sure. So hopefully everybody here can see my screen. What we have over here is our repo that we showed earlier. And then if we look at our DAG, we see that we have our MLflow metrics coming out of the training. Now, where did this come from? If we go back to the training notebook, remember MLflow, we installed it, and then we went ahead also and we set the tracking URI for our specific repo. We went ahead and authenticated everything we needed to, and we set a new experiment name. Now with this, it randomly generates a name for the experiment name, which allows us to continue running experiments. The other thing we did here is that we made sure to report it to MLflow. So the entire experiment is being reported to MLflow. We can see that on the page here under experiments. So when we click there, we're able to take a look at the experiments that we generated with the different models and the data sets, as well as our metrics. So that's basically the wrap up for MLflow. Now let me switch to my VS Code to show you DVC. Hopefully everybody can see this. So for DVC, we want to make sure we are cloning the repo first. So we want to clone the repo and then jump into that folder. Then we're going to make a directory called data. And in this data directory, we will be able to initialize DVC and add any of the information, any of the data we need to our data folder. After that, we can go ahead and authenticate. And when we authenticate, we're going to be authenticating with DagsHub for DVC. And then we will commit everything, all of our images or anything we need to a repo. And then finally, we will go ahead and push. When this is all done properly, what you end up seeing is something like this within our DAG, where you have our data, and here's the DAG showing our data going through and how it's processed for it to be taken in for training. Now, finally, as far as Hugging Face, what we also did earlier in the fine-tuning notebook is we logged into the Hugging Face notebook login. And so I think I lost screen share there.
Oh, yeah.
Let me just make sure I can get that. There we go. Can everybody see this?
Yeah.
Okay. So so with Hugging Face, I was able to push everything. It's a parameter within the script that we can just put in the token and then push the hub. This is really cool because what that means is that during training, we're also able to push our model and have it start preparing itself for deployment. So what we end up with is something like this, where in our models for Hugging Face, we have our pushed models ready to go, which this allows for the next step in deployment.
Wow. Okay. That was really cool. So it looks like DVC, Ali, is a lot like the Git commands that we're used to, just to leverage it directly in VS Code. Is that right?
Yeah.
Yeah. And MLflow is almost just like a few lines to do experiment tracking. Very, very cool. So once we've done all of this and we've started to really build out our DAG, we've done our iterations, now it's time to do the thing that really maximizes the value created for users, for stakeholders, for your boss, for anybody. This is where we get that magical URL that we can text to our mom, to our sister, to our brother, to somebody that is going to be excited about this AI app that we just built. This is where we finally get out of the notebook and get out of Google Colab. And what's so cool about this is it's so easy to do if we've done our model version control the way Ali just showed in Hugging Face. So Hugging Face, you've probably heard of them. They're one of the biggest, hottest AI startups out there today. And Hugging Face Spaces is a very, very powerful tool to just create simple AI applications. If you ever want to show someone else who's not a coder about your AI app and how it works, definitely think about leveraging a Hugging Face space. It's a lot easier than AWS, a lot easier than GCP, a lot easier to just get going if you follow the steps that we've been showing today. It's also a way to do it for free, which is absolutely critical. You just need to create a model card, as Ali will show. And once you've done that, then it's really a one-click deploy with the tool that you use in collaboration with Hugging Face Spaces called Gradio. And then you'll get a beautiful little app, as we see over here on the right, where it's almost already built in, setting up that UI for you that is just that simple input text and generates the output image. So Ali, can you go ahead and show them how to get this done?
Sure. So based off of the model that we just pushed, we'll have this ready to go, but there's no model card. And because of that, we can't deploy right away. So if we click over here to create a model card, what we can do is we can select the license. Typically OpenRail is good enough for this. I like to use that. For the language, it's just 2 letters. So we'll say English, and then the library. But we use Hugging Face diffusers. So we'll go ahead and put that in as well. As far as the tags, when you look at a Dilbert comic strip, you can say that's pretty artistic. So we'll choose art for that one. And then for the data set, we'll type out our account name. And then from there, we'll be able to see the different data sets that we have. I, for this one specifically, use the comic sample data set. So that should be good enough. We'll go ahead and commit this. And after clicking on the model card, you'll see this over here. After you click on the model card, you should be able to have everything ready for deployment. So what you'll have is this deploy button, and then you can click on spaces. And from there, it will have this code ready to go. And in one click, you can create a new space. From here, we can select the license for OpenRail, Grid IO, default. We're actually good to go. If we create the space, and this one I've already created the space. If you create the space, it will go ahead and right away start creating the space. And you'll have something that looks like this. So if I go back here for this space that I've created, it will automatically create this kind of interface with your input and your output, and you can go ahead and start submitting the prompts that you need.
So cool, man, that was really easy. It seems like it's getting easier every month to deploy applications. One-click deploy, man, these things, it's amazing the low code capabilities that are out there on the market today. So with that, we sort of have just gone all the way end to end with proof of concept through iterating all the way up to deploying our final application. So, we can say for sure, we knew this kind of coming in, but, we were reminded yet again that ChatGPT and diffusers just they're amazing tools. And prompt engineering is not going anywhere. You all, if you have not played with ChatGPT, you have not played with diffusers yet, it's time to get some hands-on experience going with that. It's going to be a huge value add to whatever you do next in your career, that's for sure. We also saw that the diffusers library, in particular Stable Diffusion, is looking at both style as well as objects. And while we were happy with our ability to replicate the Dilbert style, we definitely could use a lot of work on getting coworker 1, coworker 2, the AI right. And so that is going to be left for future work. Ali is certainly not going to be tweeting at Scott Adams until he's happy with the final results. And we also saw that DagsHub simplifies data science projects for collaborating across groups. So it helps you not only visualize the project structure, which is potentially as powerful in explaining how your AI application works as maybe even the actual deployed application itself. maybe not that powerful. But if you have these two things together and you bring that to your boss, you are all of a sudden going to be one of the all-stars on the team. And to really automate that experimentation, to get out of tracking experiments with a notepad next to your desk or with some spreadsheet, and to really do that in a streamlined way with MLflow, that's just another huge, huge way that you can create value very, very easily with just a few lines of code. Similarly, starting to leverage DVC when you change things up in your data, it's just so much easier than doing it all manually through Git and through GitHub. So we highly, highly recommend that, not to mention the DAG updates automatically when you do these things. Lastly, we saw Spaces and Gradio can really help you make a much bigger impact when you're going and sharing your AI application with stakeholders and others. So we'd love to see you all start building, shipping, and sharing today. We've shared some stuff with you. We'd love to see what you're going to build. Call us out on LinkedIn, shoot us a DM, let us know how we can be useful to you. We nerd out on this stuff, and we'd love to hear from you, what you're building, what you're interested in doing. And we'd love to root for you along the way as you take the next step in your ML career. So we've got some shared resources from today's event. And with that, we're going to go ahead and take any questions. You can reach out to us directly at these emails. These are our Twitter handles. We're also available on LinkedIn. But I think we've got some questions, Ali, that we're going to go ahead and get to now. So thanks, everybody. That concludes the sort of formal presentation.
I would also like to give a shout out to Chris Lexiak for all his help.
Chris, you are the man. Thank you for everything. Absolutely, Chris is awesome. So we've got, and I do see a number of questions. This is being recorded. Yes, this is being recorded. You will have access to the recording. We're going to make sure that you all have that. Looks like some of you are able to record it locally as well. So that's also great. And it looks like we've got a few questions. Let's start off with Chester Copperpot asks, Ali, is there a preferred way to set up a repo to replicate the Dilbert DAG?
To replicate the Dilbert DAG. So the DAG, you're saying I'm assuming you're saying like the Dilbert GitHub DAG. So for something like that, what you'd want to do is you want to make sure that you push your DVC. So push all your data through DVC. Make sure that your Jupyter notebooks are there in DagsHub, and that your code is being version controlled within there. So that is very, very important. And then making sure that the dvc.yaml file is configured properly. Your dvc.yaml file fully configures your DAG. So that's one that you need to keep an eye on as well, to make sure your DAG is looking the way you want.
And so someone can look at the YAML file that's in the DagsHub repo that we've created and basically see how that looks directly in the DAG and start to really learn kind of how to create the YAML files themselves. Okay, very cool. All right, so Christos Maganas asks, any idea why some text is backwards?
Yeah, so with Stable Diffusion or Midjourney or any of these, it's not really reading the text. It's just kind of like mimicking what's there and trying to have an idea as far as points next to each other. So as far as context of being a zoomed out view for the text, that's something that would require an understanding as far as like this text has meaning. And for algorithms like Stable Diffusion, Midjourney, they don't understand that the back end, like these words actually have meanings, these letters have meanings. So you'll have these letters backwards, forwards, mixed up, and so on.
Awesome. So Sing or Why Sing asks, is the data in the data folder pushed to Git as well?
Yeah, so you want to make sure that it's pushed to Git and then DVC. So it's pushed to Git as far as it being in the repo, pushed to DVC as far as it being tracked by DVC.
Okay, and follow-up question, can we view the data in DagsHub?
Yes, you can. The way I have it is usually through a zip, which if you have it through a zip, it will not be viewed like that. But if you have them just added as a directory, you can view all of your images. Not just that, but DagsHub also connects you to Label Studio. And through Label Studio, you can go ahead and annotate any of the images or anything else that you need, such as image captioning, all of that. So it's a great tool.
Very cool. Very cool. I'm not sure that I've got Mohammed Wasim's question. You mean ChatGPT will work with images as well? And then he said, I think it's a follow-up to the first question. I guess, does ChatGPT work with images, Ali?
No, ChatGPT does not work with images.
Okay.
There are more recent extensions that allow it to work with things like the internet and so on to try to understand context outside of the images, like that are about images, but not directly with images. We use ChatGPT in this case. Initially, I was really excited about the whole thing of the Dilbert and, tweeting to Scott Adams. And so what I did is my first go-to is ChatGPT, create me a Dilbert panel, right? Like I wanted all of the panels ready to go. And the one that you saw today, that was the first one that was generated, which I thought was pretty cool. I read that and I laughed and I thought ChatGPT just made me laugh. And so I thought, what can I do with this? How can I take this to the next step? So I tried with Midjourney and it's like going through this process, but currently at its state, ChatGPT cannot do images now.
Okay. And Mohammed actually is following up on this. And I think this is our last question. So if you guys want to ask more questions, we've still got some time. So feel free to smash the chat or smash Discord and we'll get to them. Is it necessary, Ali, to have text on images for this that we're doing?
It's not. So one step that we could propose as far as a pre-processing step is what if we can get rid of all that text? Because if we get rid of all that text, now we're training on a data set that is more about the images itself, and it won't be looking at that, and we'll get cleaner images. What that will result in is that we can now train a model that results in cleaner images, and then we can do some post-processing at the end to add text that we want through little talking dialogue bubbles for the text that we'd like. And I think that's where this will probably go. I want to add on also, this is a huge passion project of mine right now. And so what I want to do is I want to train on a bigger data set, potentially that is well configured and more cleaned up. And that will hopefully create better results and have us be more on the path toward this. So I'm excited.
Yeah. It looks like we might have some people asking some questions, but I wanted to follow up on that with you, Ali, that this idea of training, can you tell us about sort of some of the challenges that you ran into trying to do training, particularly on specific hardware, and why you went with the NVIDIA A100?
Sure. So right now, it's basically a hardware limitation as far as like, well, do you go buy a high-end video card for like at least $1,200 with 24 gigs of RAM? Because the problem with the training on some of this is just the memory. You need the video RAM. And so you need at least 20 gigs of video RAM. And to give you an idea, currently a lot of hardware, especially in the past 3 years for GPUs that's relatively affordable, is more on the 11 gigs or so. So if you want to get that 24 gigs, you really got to splurge like $1,500 for that video card. And I don't know about everybody else, but that's not something I can quickly splurge on. So with that, then you have a couple other options. You have things like Google Colab, which is $10 for like roughly 7 hours or so of premium GPU usage, which, I threw in a good chunk of money just to make sure like I can get some good GPU usage on that. And then the other option you have is M1. So Apple, with their unified memory, you can use the system memory as GPU memory. And so the current system I have is 64 gigs. And I bought this specifically for projects like this. And so I'm kind of just like trying right now. I was able to successfully run inference on the M1 chip. And the next step is to see if I can do training on the M1 chip. And if I could do that, I think it opens up a lot of doors for being able to experiment more. So.
Wow, that's so cool. So you're saying on Apple, you can actually use system memory as GPU memory.
Yeah.
That is
being able to do all this for free.
Wow. Okay. That's very, very cool. But so you all might run into some issues if you try to use the Google Colab notebook directly without signing up for Google Colab Pro.
Yeah. So it's
Um,
necessary to sign up for Google Colab Pro in order to run this, just for the GPU memory.
Yeah. So we're at the state of the art, people. This is kind of what we run into. Okay, so I don't see any more questions in the chat, so I'm going to go ahead and say, hey, thanks, Ali. That was awesome, man. As Ali mentioned, we both, yeah, thank you all of you for coming today. We also both want to give our colleague and friend Chris Alexiak a huge shout out. Thanks for helping us diagnose issues uncovered during fine tuning. And thank you again, all of you, for your participation today. Great questions. We really enjoyed being here with all of you. This interactive collaborative demo has been brought to you by FourthBrain and DagsHub. And as we post this video on the DagsHub YouTube channel in the next few days, please give it a like and sub to the YouTube channel for more content like this. Also, check out FourthBrain, check out Ali and I. Follow us on LinkedIn to stay up to date with upcoming events, content, and resources for folks like you. Feel free to follow the FourthBrain page and to connect with us. And if you'd like to reach out and you have questions that we can answer directly, if there's any way we might be of use to you as you continue your career journey into machine learning in the 21st century, we'd love to see how we might be able to do that. DagsHub, you may also hear from them in terms of a follow-up about how you enjoyed this event and how you might like to see similar stuff in the future. So that brings us to the end of today's event. Until next time, everybody, keep learning. See ya.
Thanks, everyone.